Good evening and welcome everyone to our YHS webinar on compound drought and heat events. Before the talk, let me give you a brief bio of the speaker. Dr. Somil Swarnkar is an assistant professor in Earth and Environmental Sciences at IISER Bhopal. He holds a PhD in Earth Sciences from IIT Kanpur, where he studied sediment dynamics in the Ganga River basin. Following his PhD, he was a National Postdoctoral Fellow at the Interdisciplinary Center for Water Research, IIC Bangalore. His research focuses on human climate-water interactions in Indian river basins. He has projects funded by SERB and the Ministry of Education. He has also organized several academic workshops, including the SERB Karyashala. Without further delay, let me hand over the mic to our speaker. Dr. Somil, the stage is yours. Let me know whether you can share screen and
Thank you so much, Avinash, for giving me such a nice introduction. I would try sharing my slides. Screen. I hope my screen is visible.
yes, it's visible.
Okay. This full screen is working also, and slides are moving.
Yes,
Okay.
it is.
Fine. So thank you so much, Avinash, for introduction. So my today we are going to talk about a very important topic, very relevant to the central Indian region, compound drought and heat events in Madhya Pradesh, a district-wise analysis. So in this particular talk, this is one of my students' work here at IISER Bhopal. So we have, it's part of his BSMS. So we have tried using the historical data analysis and tried to look at what is the drought and heat events which are occurring at the same time and what is their pattern through different district-wise analysis. Why we have selected Madhya Pradesh? Because Madhya Pradesh is very, very famous for some of the very notorious drought in the past several years. And there are, because of this, we have already seen several, socioeconomic damages, particularly agricultural yield, or basically the different districts in Madhya Pradesh are directly or indirectly are related to agricultural activities. Therefore, there are lots of people which are involved in these activities, and therefore when these extreme events or catastrophic events occurs, that directly hits their socioeconomic conditions, and therefore it is very important to assess. So for example, if we look at here, so this is a smaller region of Madhya Pradesh, Bundelkhand, which is one of the highly recognized as the frequent occurrence of the meteorological and hydrological drought in, let's say, in the past 10-20 years, like that. And we have also seen at the same time in recent years that extreme heats or extreme weather phenomena are also increasing across different districts. And sometimes, when these types of heat events and drought events are occurring at the same time. So when I'm saying that compound extremes, which is generally there are two extremes. One is your low rainfall extremes, basically a drought event. Particularly, we are referring to the meteorological drought event. And there is another event, which is basically we say the heat extremes, where temperature rise to above a certain thresholds in different districts like that. So if you look at this 27th May 2024 figure, which basically tells that there are several districts which are dry, which they have very, very low rainfall, of course, because of the pre-monsoon, but during the monsoon also they receives a very lesser amount of rainfall. At the same times, they have also have a very higher amount of the magnitude of heat extremes across these different parts of the districts across Madhya Pradesh, particularly if you talk about northern Madhya Pradesh regions like that. So when these extremes are occurring at the same time, they can create this problem of the compound, the extremes more effect, more highly more compounding nature of the extreme events, and that basically creates more disastrous results compared to if you're looking at particularly one extremes at the same time. So what we have done in this particular work, we have selected the long-term, precipitation data set, monthly data set, and we have taken the monthly temperature data across different districts. So this is one of the methodology I have adopted. We have adopted from Guntu and Agarwal 2024 papers. So basically, we have used the monthly precipitation data for different districts, and we have tried to look at the threshold at which the precipitation is lower than that particular threshold. So for example, if we are setting the threshold 38th percentile like that, so we are trying to find out what are those months in different historical period where the rainfall amount was lesser than 38th percentiles across, let's say 1965. Here it is showing that we have taken data set from 1960s to 2022 like that. So basically we are looked at how many months across this particular time period which the rainfall was lower than 30th percentile. And then we have also looked at, let's say, temperature threshold where it is crossing above 70th percentile. So at one times we are looking at the low rainfall months. We are marking it with using some 30th percentile threshold. At the same time, we are also marking those months where the temperature is crossing above 70th percentile. So, and then we are clubbing it together to make it which months where we have a co-occurrences of these different events. So suppose we are taking the temperature at 30th percentile and the precipitation as 30th percentile and temperature at 70th percentile. And then we are looking at how many months in the historical time period where this types of phenomena has co-occurred in the historical period. Similarly, this is we have termed as when we are talking about 30th rainfall, 30th percentile rainfall and 70th percentile temperature as high compound drought heat extremes. And when we are talking about, let's say, precipitation which are below than 10th percentile of threshold and the temperature is basically higher than 90th percentile threshold, that is basically we termed as extreme category of the compound drought and heat extremes across different districts. So this method we have applied across different districts, and we try to find out how many months in the historical time period we have observed this particular relationship. So that is basically we have tried to figure out the occurrences, how many months in the historical period where these types of co-occurrence of these extreme events has been we have observed. And then we have also at the same times we have tried to calculate the severity of these different events. For example, when we have already calculated the what is the total magnitude of rainfall we have received across different months, and we have what is the total magnitude we have seen the temperature rise across different months, we can also make some sort of empirical joint probability density functions, and then basically we can convert back into the probabilities into inverse normal transformation, and then we can also calculate what is the severity across different months and different events, and then we can calculate what is the overall severity. For example, when we have observed the severity is less than, let's say, 0, or let's say in this particular range, that is basically termed as mild CDHE or compound drought or heat event or heat extremes like that. Then let's say if it is goes beyond -1 to -1.5, we have basically it is termed as the moderate CDHEs. When it is basically goes beyond, let's say, -1.5 to -2, that is basically termed as severe compound drought and hot event category. And if it is beyond that -2, that is basically extreme categories of that particular extreme CDHE events across that particular. So this is how basically we have categorized the severity level of the compound extremes by using this particular classification. And then we can also look at how many times, let's say in the past, if the compound extremes has been occurred, what is their overall severity across. So for particularly this work, we have selected the Madhya Pradesh district, different districts. Total we have selected around 51 districts here. And we have performed all these analyses at the district level so that we can have an understanding about, let's say, what is the overall compound drought and heat extremes behavior in the northern districts of Madhya Pradesh and eastern districts of Madhya Pradesh, or let's say southern part of the Madhya Pradesh, like that. And which of those districts, for example, are the one of the worst affected in terms of the high CDHEs or extreme CDHEs events in the past historical periods, like that. So this is what we have already done. So this is one of the methodology we have adopted. So we have basically selected the districts. We have collected the data from TerraClimate, which is high resolution data of rainfall and temperature that provides monthly rainfall. We have used this particular data set from the Google Earth Engine platform. We have extracted the monthly time series of the rainfall and the temperature data set from different districts, and then we have processed it through the MATLAB and Python programmings, like that. And we have calculated the SPI, standardized precipitation index, standardized temperature index. Then based on these indexes, we have calculated what is the compound occurrences of compound drought and heat events across different districts, as well as by using the joint probability concept, we have taken the inverse of that normal transformation to calculate the severity of the compound drought and heat extremes across different districts. Once we have got the results from different parts of the districts, or in the Madhya Pradesh, we have tried, basically we have mapped it using RGIS, and we have basically looked at what is the spatial pattern and what is the temporal pattern across different districts in the Madhya Pradesh, like that. So this is so first what I will do, I'll explain all these input data sets, their characteristics, their spatial behavior, like that. And then we will go to the particularly results part, where I will discuss about how our results basically what kind of the pattern we have observed from this analysis. So this is basically the rainfall data set division, where we have divided our data set into three monthly part: pre-monsoon, monsoon, and post-monsoon. And we have also divided our data into two different time period, that is pre-19, post-90. Why we have done that? Because we assume that this pre-90 is a kind of a baseline period, and we will try to look at since the baseline period how much the changes we have observed across different districts, like that. So for example, pre-monsoon, we do not see any significant rainfall. However, the rainfall was less than 100 mm. There are few parts of the Madhya Pradesh we observed that the rainfall has been slightly increased 50 mm, and there are let's say western Madhya Pradesh, a region where we observed the rainfall has slightly decreased in the post 1990 period. Then when we looked at the monsoon results, there are the eastern Madhya Pradesh particularly, and the southern part of the Madhya Pradesh, where it receives a significant amount of rainfall, more than 100 mm. And let's say if you talk about here the northern and particularly the Bundelkhand part of the region, where we observed that the rainfall is relatively lower compared to other part of the Madhya Pradesh. So when we take in the this difference between post 90 and pre 90, we observed that there is a significant changes in the rainfall pattern, particularly in the eastern Madhya Pradesh region, where we have observed the rainfall was lesser than 50 mm. That is the average value pre 90 and post 90. And then we have compared it like minus 50 mm decrement from the average what we have observed in the baseline period of pre 90 conditions, like that. Then we have observed the post monsoon rainfall, particularly so monsoon we have divided June, July, August, and September. And then the post monsoon is October, November, and December. And then pre monsoon is January, February, March, and April, and May. So this is the month division we have taken to basically do that analysis. So for the post monsoon, we have observed there is a slight decrement in the rainfall pattern across different districts, which are primarily in between 0 to minus 20 mm across all the districts. So this is just a average number which we observed. That basically tells that significant rainfall changes we observed particularly during the monsoon seasons, like that. uh, Then we looked at the temperature data set across different districts of Madhya Pradesh, and we compared, let's say, pre-90, pre-monsoon temperature average across different districts and post-90 temperature data. And then we have taken the difference that basically tells that most of the districts during the pre-monsoon, which is a summer period, has seen rise in the temperature up to 0.4 degree. Then there are several districts in the let's say this western Madhya Pradesh and the northern Madhya Pradesh part where we observed the temperature has risen up greater than 0.5 degrees as well. Then we looked at the monsoon part of the rainfall pattern, this temperature pattern. Basically, it tells about there is a significant changes throughout particular period where we observed that particularly that Bundelkhand and all these region where we have observed a very significant a higher amount of magnitude. And when we're taking the difference between these different districts, we observe that there is a 0.5 degree rise of the temperature in different parts. Also, there are few districts in the northern part, western Madhya Pradesh and some eastern Madhya Pradesh, where we have also observed the temperature has gone up by 0.5 degrees as well. Then by looking at the winter precipitation data set, we observed that winter temperature data set, we observed that there is a significant change we observed in the particularly in the winter season, where we seen that the average temperature during the pre-90 and post-90, after post-90 we observed the temperature has risen in the eastern Madhya Pradesh particularly above 0.5 degree, and some other regions more than 0.5 degree. So by looking this figure, it is basically observed that major changes what we have seen in the Madhya Pradesh particularly is during the winter season, and therefore a significant rise in the temperature we observed in the eastern and northern districts of Madhya Pradesh across because of the temperature anomalies profile. Then, so this is basically, so this is primarily the input data set comparison, how the Terra climate data set has been behaved across different time window, pre-19, post-19 and different season, and how we are getting the, let's say, the differences between different districts like that. Then we have looked at, different temperature and rainfall monthly data set for individual districts. So here I have shown only for the Bhopal district. So we have obtained the precipitation data set from Terra climate, and then we have converted into a standardized precipitation index, and then we have converted the temperature data into standardized temperature index in Bhopal. So that is basically the plot, and then we basically used one particular threshold where we selected T30 and T70, where 30th percentile we are assuming the lower than that threshold is SPI is lower or precipitation is lower, that is classified as drought year or drought months for that particular district. And if the temperature is basically gone up by more than 70th percentile for different districts, then it is considered as the heat extreme events like that. Then we have compared both the condition at the same time, and then we marked occurrences of the compound drought, dry and hot events in Bhopal across different years like that. So you can see that whatever the red lines are showing here, it is basically showing that this is the events which has occurred in the historical period. It is also visible here. If you look at pre-90 particularly, here there was a occurrences of the CDHE compound drought heat events occurrences here. But when we are looking at post 1990 period, there is the CDHEs occurrences are very dense or very frequent manner in the post 1990 period particularly. Then we also calculated the standardized compound event indicator, that is SCI for the Bhopal, and that is basically we calculated what is the severity of individual compound drought and heat events CDHEs across that particular different districts as well. So here it is showing that if you look at pre-1990 data set, there are some events which are more than or less than -1 degree, -1 threshold. But if you look at particularly after 2000, we have observed there is a frequent occurrence of compound drought and heat extremes, which has a very low values, lower than -1, which is basically showing that very severe type of extreme events are occurring, and their frequency has been also increased in post 1990 period. So this is one example of Bhopal district. The similar approach we have adopted for all the districts across MP, and then we have mapped it, the occurrences across a different time period. For example, we have divided our analysis into three parts: pre-monsoon, monsoon, and post-monsoon, and then pre and 90 and post-90. We have calculated what is the occurrences of CDHEs in different parts of the districts. We observed that most of the districts which are located in the eastern part of Madhya Pradesh and the northern part of the Madhya Pradesh, where the extreme events has been significantly increased, their occurrences has been significantly increased. When we look at the monsoon period, which we have also shown that here, that there is a significant rise of these extreme events in the northern and basically the northern and eastern part of the Madhya Pradesh. And similarly, we have also observed the post-monsoon differences, which is the region here where we have observed the significant rise of the occurrences of CDHEs in the northern and eastern Madhya Pradesh regions. Similarly, the difference results also shows that how much difference of number of events we observed from post 1990 and pre 1990 for different seasonal divisions patterns like that. Then so this is basically when we are doing that analysis for high CDHE occurrences, we are considering the threshold as P30 and T70. When we are talking about the CDHE occurrences, we are talking about the threshold as P10 and T90, which means the 10th percentile of the precipitation and 90th percentile of the temperature extremes. So here we also observed there is a number of events which has been also increased severely in terms of extreme CDHE occurrences, particularly in the northern and eastern part of the MP. We have also observed during the monsoon as well, and there is a significant rise in post-monsoon. Multiple districts in the MP has been seen a significant rise of the CDHE across a very broader region of MPs across like that. So the different results also showing the same informations here as well. Then we have calculated the severity across different part of the MP, and that is basically showing that in the pre-1990 period, however, there was lesser occurrences, but there are some events which has a higher severities. But in the post-1990 period, we have seen a higher occurrences with higher severities, which means if you look at here as well, so there is post 1990 there is a higher, so median value has been shifted below -2 1.2, and that is basically we have seen a very higher occurrences of CDHEs lesser than -1 or lesser than -1.2 in the post 1990 particular period. Similarly, we have also seen there is a significant difference in terms of the severity level of the CDHEs across different districts, and we have seen that there is a lower severity, or basically the increased severity in post 1990 period as well. Then we have also seen that this basically the post monsoon analysis, and we have also seen there is a significant rise in the severity level of CDHEs across post monsoon, particularly winter month as well. Then we have also looked at extreme CDHE SCI, which is basically we have classified as E10 and T90 threshold. And that is basically also showing that there are few instances in the historical period where we observed there is a significant higher amount of severities we observed, but their occurrences were low. But when we are talking about the post 1990 period, there are lots of areas, lots of districts in the MP where we have seen the severity has been significantly increased, and that is basically showing that there is a rise of the extreme CDHEs across different part of the MP as well. Then we worked on so what is how we can club it all these results together. So how we can tell that to the policymakers or to the government that okay, these are the districts where which are significantly affected by the compound drought and heat extremes across different MP districts like that. So what we have calculated, we have basically calculated the average cumulative severities. We are basically multiplying the number of occurrences with the amount of severity we have calculated, and then we have basically taken the average, and then based on that for different seasons we have estimated or top 10 districts across MP, which has basically showing the significant severity level of CDHE. So, for example, we observed that Siddhi and Shahdol and Satna and Singrauli, like that, these are the eastern Madhya Pradesh districts which are significantly affected by uh, the CDHE's occurrences, particularly those districts Patna, Katni, and Bhind and Rewa and Morena. Bhind, Morena, and like this, these are part of Budelkhand region. Here we have also observed a very significant, presence of the cumulative severities across the Madhya Pradesh districts like that. So, what is the overall conclusion of this study is what we observed, this study reveals a significant increase in the frequencies as well as the severities. And we have also observed a very significant rise in the spatial extent of CDHEs in Madhya Pradesh, especially in northern and eastern districts, which we have also calculated by taking the calculating the top 10 districts across different in the MP, particularly post 1990. For this whole analysis, we have used this Terra climate dataset. Why we have used? Because one of the reason is this dataset gives you a very fine resolution data, and that can be helpful by identifying more precise location of within the inside a district, that which of those locations where we are observing a significant rise of the CDHEs, and how we can, let's say, provide some sort of sustainable management in terms of water availabilities, or some sort of, let's say, drought resistance seeds as well, like that, or agricultural smart agricultural activities. So these are the reason behind it. We have used this particular data set to identify warming across the seasons, as well as we have also using this data set, we have observed the monsoon rainfall, particularly the districts in the eastern Madhya Pradesh are, and Satna, we have observed a hotspot for CDHEs. Then by doing these kind of the analysis, SPI and STI, we have also done some sort of LMFDH, the likelihood multiplication factor of dry. And so to in order to understand which factors is playing the most critical role in the different districts, like that, that is basically can be indication of, we can do that for other parts of the country as well, to identify the patterns, intensify dependencies on high temperature and low rainfall, for amplifying the CDHE severities. Or by looking at different districts level analysis, we can also think about providing the integrated water resource management, rainwater harvesting, or groundwater recharge, or let's say some sort of water efficient methods, for example drip and sprinkler system. Or let's say we can also talk about, or we can provide, or we can give them suggestion that we can think about in applying the heat and drought tolerant crops, so that we can minimize the significant or negative impact of these CDHs across different districts as well. The another important thing is, when we are doing these kind of analysis for district level, we can also do some sort of local governments information to them as well, the climate forecast or historical pattern forecast to those local governments, so that they can take our input, or they can take these ideas, and they can adopt in their policy making things as well. Or the other important aspect of doing this particular research is to make the community awareness about, so what is has happened in the historical period, and what is likely to be happen in these districts, so that we should be better prepared for, let's say, +2 +4 degree or different climate scenarios conditions as well. So that is what the overall the message from this particular study is like that. So thank you so much. If you have any doubt, you can ask.
Thanks a lot, Dr. Somil Swarnkar. That's a wonderful talk. It's also good you touched upon resilience and adaptation point of view, because mostly we researchers, even including me, we only talk about meteorological part rather than looking at the adaptation part. And I want to ask, is this work already published or it's yet to be?
So it's we have received a minor revision, and it is almost accepted. Probably it will come. We are waiting for final confirmations. Yes.
Okay. I hope participants have a lot of questions. If they can unmute and ask the question. themselves. Otherwise, I can read from the chat. Okay, there is one question in the chat. Do you like me to read or you can, or
Yeah,
what is
I'll
your
read.
Oh,
So
sure.
thank you for interesting. Okay, my doubt is how would the results change if we change the threshold value? Also, is it valid to consider same percentile threshold across all districts as climate time series might have varying skewness across different districts as well? So yes, if we change the threshold, of course, the results will change. For example, if you're talking about P30 and T70, we are having more occurrences of CDHEs. But when we are talking about, let's say, taking P10 and T90, of course, the occurrences of the CDHE will reduce. So that will change. The another part is it valid to consider same percentile threshold across all districts as the climate time series might have varying skewness? Yeah, it is a good observations. Yes, because uh, when we are talking taking these monthly average data, we have not taken a direct percentile. We have taken a monthly percentile across different years. For example, when you're talking about, let's say, January month, so we have taken the percentile for only January, we have taken percentile for only February, and like that. So yes, it is possible that when we are dealing with different districts, it might possible because of different hydroclimatic zones as well. Their effect will be different, and we might think about taking different thresholds as well.
Okay, I have a question. Can I ask?
Sure, sure. Please go ahead.
So I'm not great in this field, so I just want to clarify. What is the threshold value of precipitation and at what temperature we called it like a compound heat and draft condition, compound heat
Basic,
stress condition?
yeah, yeah. So basically, let's say we have a data set from 1985 to 2015. Okay, this is 31 years data. And we have one particular district, let's say. So for Bhopal, we have 31 years of data monthly, let's say rainfall and temperature. Okay, so for 31 years, you have 31 January, you have 31 February, 31 March, 31 December, like that. So for
Yeah.
January, you have 31 values. Now you can use these 31 values to calculate 30th percentile rainfall. Okay, so basically you can calculate 30th percentile of rainfall. That would be the threshold. So if the months where the rainfall are below 30th percentile, that is marked as dry month. Okay, similarly, we have done for temperature. So let's say we have 31 different months. So we have applied the 70th percentile for January. And let's say if that month where the temperature rise or increases above 70th percentile, that is marked as hot extreme. So for example, if you compare January to December or January to, let's say, June, that would not be a correct comparison, because January has we have lower temperature, particularly in central India. And when we're talking about June, there we have a very high temperature. So therefore we have to do this analysis in monthly basis. So we are looking at basically in 1985 to 2015, which was those Januaries where the temperature was really high. So that is what how we have calculated it.
And another one, can we replicate this same procedure for the different geographical condition or in different part of the world, or it's localized? This procedure is localized to one country and one region.
This can be applied in anywhere, because this is a very the approaches and methods have already published, and people are
Okay.
applying it many part of even India, and Dr. Ankit has also applied entire Indian conditions as well. So people from China have also applied different parts of region, like, so it is you can apply it for even we have also read many papers where people have done this analysis for entire globe, and they have tried to find out those areas which are those hotspots.
There is a
Yes.
question from Dr.
Yes. Dr. Pankaj, that's a very nice question. So basically, we can check the large scale teleconnection with the compound. Yes, that is a very nice. Basically, we are working towards it. That is, we have already, that can be done. Let's say ENSO. We can compare with the ENSO and we can look there any role of large scale teleconnections with the different districts, or how we can, or probably let's say we can talk about the changes in land use, land cover, local scale changes, whether because of the change of the land use land cover conditions, whether the dry conditions has been exacerbated because of the sensible heat or latent flux like that, or let's say or many other human activities as well. So we have done some sort of investigation that this has been changed in different districts across. The another part of this, basically, we are looking forward to it, so how we can combine all these different processes, and then we can look at what processes are basically responsible in different parts of the districts.
Okay, I have a question. Like you selected 1990 as a baseline period. Is it because you noticed any significant change in the shift or practical application?
So basically, when we looked at fewer districts occurrences, we have observed that there is a significant change in the occurrences. Particularly, we have seen, I have shown the one figure of Bhopal, where pre-1990 conditions, we have lesser occurrences. And then post-1919, very crowded, very squeezed pattern we observed. So that is what one way we have adopted this pre-19, post-90 baseline period like that. And there people have also recommended in the previous researchers as well, that WMO has recommended, okay, this is 1960 to 1990 can be a baseline period to in order to understand how much change has been observed in the historical period.
Yeah. I see a hand raise from Tejasvi. Tejasvi, you can unmute and ask your question.
Hi, can you hear me?
Yeah.
Yeah.
Hi, Dr. Somil. Very nice talk. I just wanted to ask a very small doubt. If in these analysis, when we, for example, like you did, you choose a baseline period of 1990. In such a scenario, do we compute SPI only before baseline period and then use thresholds from that time to see the change, or do you compute SPI or STI? Is threshold analysis done on full time series, even if there is a baseline in between, to generate probability density functions? Um,
Yeah. So basically, when we're talking about SPI, so standardized precipitation index, we are calculating for entire duration, duration basically. So if
okay.
we break it down into two parts, probably the SPI value will also change, right? Because
Yeah.
it's a
My doubt
index.
is
It's a kind of a
because
relative index. Yeah.
my doubt is because you showed that after 1990 the mean rainfall has changed. So in some sense,
Yeah.
probability density function has shifted.
Yes.
And in this scenario, shouldn't it would it be better if we do it separately, or should we is it okay if we consider the whole time series?
Yes, you are right that if that precipitation has been changed, probability density functions probably also be changed. That is kind of a non-stationary conditions. Yes. So basically, when we looking at this, we have not assumed any particular probability density functions. We have used as a empirical density functions,
Okay.
ECDFs. So
Okay.
therefore, we have not assumed any particular probability, and we have calculated everything based on whatever the data is saying. So that is what we are relying upon.
Yeah, I see. Thank you.
See some questions in the chat.
Yeah. So, respected sir, I am undergraduate student. Grateful if you could kindly guide me regarding the procedures to carry out such research work. Data required. Okay. So basically, whatever data we have collected in this particular work, we have obtained from Google Earth Engine. So that is a kind of a cloud-based platform where multiple types of data sets are already stored. That could be, you can find out the rainfall reanalysis data set, various different types. You can also have the Landsat, the satellite data set, or different types of land use, land cover, soil types. Many types of data sets are already stored. What is the purpose of this particular types of cloud platform is you don't need to download those data set in your local server or local machine. You can do that analysis and extract, particularly, let's say if you are interested in monthly trend or monthly data set, you can just tell, okay, I am interested in Delhi or Bhopal or Indore, like that, this particular region, and you give the data, that particular platform, that save file, and it will give you directly the monthly data set or hourly data set or daily data sets, like that. So using these types of tools, you would be able to generate the data set, or you can also download, let's say, some of the data set which are not available in Google Earth Engine. Then you can directly download the data, or you can use some sort of Python programming or MATLAB programming to extract. Let's say you are dealing with NetCDF file. So there we have a dedicated packages that you can use it, and then you can extract the information, and you can make it as a time series or a spatial data plots, like that. Another question, any specific models tools that you would recommend for analyzing CDHEs and predictions? So basically, throughout this analysis, we have worked on, there is a already developed code. If you just message me or email me, I will send you the paper. That they have already developed it, and that is basically based on MATLAB. So we have further modified it according to our need for different districts, and then we have implemented it for Madhya Pradesh. So this tool is basically available, freely available, and therefore you can use it for your purposes if you are interested. Hello, sir. Is CHIPS data good for drought assessment or reanalysis data like ERA5 performs accurate results? Also, plus tell me how to select based on their spatiotemporal resolution through some light on downscaling method. So CHIPS data is also useful data because it is also integrating station-based and other types of data set for rainfall analysis. Reanalysis data, some of them are very good. Sometimes what observes, basically there are few regions where we have less station densities or less data availability of rainfall, like that. So in that sense, sometimes reanalysis data can provide a very good overview about that particular region. So whatever data set you are using, you should also try to correlate with the observed data set so that you have better command on that. So there are several papers been already published, reanalysis data like ERA5 or whatever we have done like Terra Climate. People have already compared these reanalysis data set with the observed data set, and they have got very good accuracy. So therefore, you can use it for your analysis as well. How to select based on their spatial resolutions. So it depends upon multiple factors. For example, if you are looking at this analysis for district level, so you have to take that data set which should have at least several grids within the districts. So let's say if you are working with 1 degree data set or 100 kilometer by 100 kilometer data set, it is too big. The grid is too big that maybe you will get only one pixel, only one grid in that particular region. So it depends upon your application. For example, if you're working for entire India level, so then if you're using high resolution data set, it might increase your computational efficiency or computational demand. And therefore you need some sort of more efficient system like that. So therefore it depends upon your region, area of interest, and you also check with if you're using particular reanalysis type data or particular data set which is derived from satellite, you should have a better confidence about whether this data set has been already validated or not. If not, then you can check with the observed data set as well.
There is
And
one
to the
question. Oh, yeah. Sorry, please go ahead.
yeah
Yeah, please go ahead, Dr. Somil. Yeah.
Yep. Yes. So
Yeah.
another question is downscaling method. Yeah, there are several downscaling methods. People are using statistical based, people are using machine learning AI based method to downscale the data set from higher resolutions to particularly lower resolutions, like that. So there are several techniques are available.
There is one question above by Sandeep Kumar. He asked about the percentage. I think we had missed the question.
Sandeep. Yeah. Is the percentile
Yeah,
set for each month exclusively? If yes, then how can we have the difference considered drought condition for different months? Yes. So yes, the percentile is set for different months exclusively. Uh, how can we have the difference considering drought condition for different month? What do we mean by this? Difference considering drought condition for different months. So basically, as I just explained earlier, that so let's say we have 1985 to 2015 data. So in this period, we have 31 years. So that would be 31 January, 31 February, like that. So for each month, we have exclusively calculated the separately the threshold T30, P70, sorry, P30 and T70, P10 and T90, like that. And then we have calculated the co-occurrences of these extreme events, and then compared with that particular period, how many numbers of occurrences we have reported in different periods of time, like that.
right. I have one more question, like that is in line with what I mean. One is the what cases we asked about the percentage because we have different change in the trend. So we believe maybe like the after the baseline post 1990 would have high influence in selecting the threshold value. Okay, that you have already answered. Another question is, from the figure you showed, from precipitation trend and the temperature trend, I saw precipitation
Yeah.
trend is kind of mixed pattern, right? Somewhere it's increasing, somewhere it's decreasing. The temperature is
Yes.
overall increasing. So can we say
Yes.
like that temperature, changing the temperature influencing this change in the compound drought events? Because CDH is also increasing overall. So
Yeah.
can we say
Yeah.
temperature is influencing a lot?
Yes. Temperature has overall a significant influence across MP. So it shows that temperature is throughout MP district has been significantly increased. But in order to have these events, both the events should be co-occurred at the same time, which means that is why in the end of the results, we focused at northern and eastern part of the MP, where we have seen significant rise of CDHEs. Those are the areas where we have seen a significant rise of the temperature at the same time, a lower amount of rainfall. So, but we cannot rule out these possibilities that in other districts where we have higher temperature, we have more probabilities of heat waves or heat conditions as well.
Yeah, right. And also the another question. I mean, I don't see any questions in the comments, so I'm just talking. I hope that's not a problem. In the figure you showed, like in pre-monsoon precipitation trend, we see like the in pre-monsoon period the precipitation is increasing. I mean major region. What's I mean
Yeah.
in the level of 50 mm or something, right? So I'm just curious, like what is the reason behind? Is there like some shift in the monsoon or something? Or I mean the process
It
behind
could
it? You
be
have any?
probably, yeah. We haven't looked at it particularly, but yeah, it appears to us also because, but the rise in the, this is average rise, like 50 mm or something like that. So it's not very significant rise, but yes, that might be possibility that there is a early arrival of rainfall patterns, or there are more some of the local influence in that particular period, particularly in the summer months as well.
Yeah. It's very interesting actually because yeah, we can say overall it's increasing, but when we fragmenting it, in multiple levels, then we see a lot of interesting patterns.
Yes. Basically, the idea was to actually provide the district level information, this compound route, and that we can convey to their local government at least, because we are seeing here a very significant, displacement or migrations because of drought and extreme events. The last year, we have also observed a very significant rise of the temperature across all the districts in MP. So, therefore, it has to be converted somehow into a number, and then we can tell to the policymakers that, okay, these are the districts where we need to have spatial attention so that it can be mitigated. So other problem with the MP also, because there are few districts where we have large water structures, and there are few districts where completely, there are surface water bodies has been covered. Land cover has been changed completely, and those wetlands or smaller ponds or like that, it has been disappeared completely. So the another problem is here, the surface has been significantly decreased, and we have been extracting too much amount of water from ground water resources. And MP, we don't have much water here actually. So in the summer period, actually, there are very severe water scarcity, and that has to be that is basically sometimes directly influenced by these human activities. So it has to be converted to, so that the policy makers or different district levels can understand the gravity of the problem. And once we have identified these hotspots, we can further go to, let's say, village level or taluka level, and can identify those areas which are actually need attention. So that was the purpose of overall this analysis.
Yeah, true, very true.
Yeah.
There is just one question. I don't know. Yeah, which drought index did
Which
you use
drought
in drought?
indices did you use? We have used only the precipitation, that is meteorological drought conditions we are saying. So there are drought indices, for example, SPI, SPEI, like that. You can also use it. SPI directly tells about meteorological drought conditions. SPEI, when you are taking the evaporation, that is basically converted to hydrological droughts scenarios as well. But we have, in this particular work, we have only used the precipitation as a dry condition and temperature as a hot extremes.
Is there any question from participants? They can unmute and ask. We still have some time. Not, then I think we can conclude the session. Thanks a lot, Dr. Somil Swarnkar, for accepting the invitation and gave this wonderful talk. We really hope, like, you communicate your results to the stakeholders, and we really want to see like how MP can lead in adaptation towards the CDHE events, because
Yeah.
there is I mean, personally, I feel there is a lot of gap between researchers and stakeholders in communicating the research works. I hope a very good change from your work.
Yes. Thank you so much, Avinash, for inviting me in YHS. This is a very excellent initiative, and I hope to see many more interesting talk in future as well.
Sure, sure. Thanks a lot. Thanks,
Thank you.
everyone, for attending. Hope to see you all in next YHS webinars. Have a great weekend.
Thank you so much.